Have you ever wondered why time seems to slow down when you're waiting for something important but flies by when you're having fun? This peculiar perception of time isn't just a figment of our imagination, but a fundamental aspect of our human experience. Every tick of the clock, every passing moment is perceived differently by different individuals and even by the same individual in different situations. Now consider this. What if time isn't as rigid and absolute as we've always thought? What if it's more of a fluid concept, bending and stretching based on different factors? This idea, as mind-bending as it may sound, forms the basis of a fascinating scientific concept known as time dilation. Yes, time, that consistent tick-tock that we've always relied on, might not be as reliable as we once believed. Rather, it is a variable entity, relative and ever-changing. Time, it seems, isn't as straightforward as we once believed. Enter the fascinating realm of time dilation, where time is not a constant, but a variable. The concept might seem a little mind-bending, but let's simplify it with an analogy. Imagine you're on a train that's zooming along at near light speed. On this train, you decide to bounce a ball up and down. To you, the ball's path is a straight line. But to an observer standing still outside the train, the ball's path is a diagonal line as the ball has to move with the train. This diagonal path is longer than the straight up and down path you see on the train. Now replace the bouncing ball with a light beam. According to Einstein's theory of relativity, the speed of light is constant, no matter if you're moving or standing still. So if the light beam has to cover a longer path for the stationary observer, it would seem to take more time from their perspective. But for you, on the train, time appears to move at its usual pace. This is the essence of time dilation. The time experienced by an observer in motion, you on the train, is stretched or dilated compared to the time experienced by an observer at rest. Einstein's theory of relativity introduced this concept. It tells us that time and space are interwoven into a single continuum known as space-time. And in this continuum, time can stretch and squeeze, making it a variable instead of a constant. So time dilation is not just a science fiction trope, but a real scientific theory. Now let's encapsulate what we've learned about time dilation. This intriguing concept is rooted in Albert Einstein's theory of relativity, which fundamentally changed our understanding of the universe. According to this theory, time does not tick away uniformly for everyone. It's not a rigid, unchanging entity, but a flexible one that can be stretched and squeezed based on the speed of motion and the force of gravity. Imagine you are aboard a high-speed spaceship. To you, inside the ship, time would seem to progress normally. But if you were to somehow peek into a stationary clock back on Earth, it would appear to be ticking slower. This is time dilation in action, where a moving observer's time runs slower compared to an observer at rest. Now let's take a leap towards the stars. The implications of time dilation for space travel are profound. A journey to a distant star might seem incredibly long to those left behind on Earth, but for the intrepid spacefarers moving at near light speeds, the trip could feel considerably shorter. This is no science fiction, but a fascinating consequence of the laws of physics as we understand them. To conclude, time dilation shows us that time is not a universal constant, but a flexible and relative concept, changing our perception of reality itself.